Is cause and effect an illusion? Nothing seems more obvious than cause and effect. The ball moves because you kicked it. The water boils because you heated it. Every event has a cause, and every cause produces an effect. This is the foundation of science, the backbone of explanation, the assumption that makes the world predictable. But when we look closely, causation becomes deeply mysterious. Philosophers have struggled for centuries to define what causation actually is. Physicists have discovered that the fundamental laws are time-symmetric, treating past and future identically. Quantum mechanics introduces randomness that breaks causal chains, and some physicists now suggest that causation itself might be emergent, not fundamental, an approximation that works at human scales but dissolves at deeper levels. Welcome back to The Conscious Observer. Today we ask whether cause and effect is real or an illusion our minds construct to make sense of the world. The philosopher David Hume posed the deepest challenge to causation in the 18th century. He asked, what do we actually observe when we see one event cause another? A billiard ball strikes a second ball and the second ball moves. But what we observe is just sequence and proximity. First one event, then another in the same place. We never observe the causing itself, the invisible power that makes one event produce another. We see patterns, regularities, constant conjunctions. But the necessary connection that we assume between cause and effect is not something we perceive. It is something we add. Hume concluded that causation is a habit of mind, not a feature of reality. We expect the future to resemble the past because it always has. But this expectation is psychological, not logical. There is no guarantee the sun will rise tomorrow, only a strong habit of expecting it. The fundamental equations of physics do not contain causation. Newton's laws, Maxwell's equations, Einstein's relativity, Schrödinger's equation, all are time-symmetric. They work equally well, run forward or backward. If you film a collision between particles and play the film in reverse, the reversed motion obeys the same laws as the original. There is nothing in the equations that distinguishes cause from effect, past from future. The arrow of time, the direction from cause to effect, is not written into fundamental physics. It emerges from special initial conditions, from the low entropy state of the early universe, not from the laws themselves. At the deepest level, physics describes correlations between events, not causal powers that flow from one to another. Causation might be a macroscopic approximation, useful for navigating the world but absent from its foundations. Quantum mechanics further undermines traditional causation. When a radioactive atom decays, nothing causes it to decay at that particular moment rather than another. Decay is genuinely random, uncaused, a spontaneous event with no prior determinant. Classical causation requires that the same cause always produces the same effect. But in quantum mechanics, identical preparations can lead to different outcomes. The universe is not a machine where the past determines the future. It is a probability space where multiple futures are possible, and no cause selects among them. Einstein hated this, insisting that God does not play dice. But every experiment confirms that quantum randomness is irreducible. At the microscopic level, causal determinism fails. Events happen without sufficient causes. Even stranger possibilities have emerged. Some interpretations of quantum mechanics allow retrocausality, where future events influence past events. The transactional interpretation proposes that quantum interactions involve waves traveling both forward and backward in time, negotiating outcomes across temporal directions. The two-state vector formalism describes particles as influenced by both initial and final boundary conditions. These approaches are controversial but not ruled out by experiment. If retrocausality is real, the simple picture of causes preceding effects breaks down. The future is not just affected by the past, it participates in determining the past. Time becomes a two-way street, and causation dissolves into a web of mutual constraint rather than a one-directional flow. Some philosophers have tried to rescue causation by defining it in terms of intervention. A cause is what makes a difference when you intervene. If you flip the switch and the light turns on, the switch caused the light. If you had not flipped it, the light would have stayed off. This interventionist account captures much of how we use causal language in science and everyday life. But it faces problems. We cannot always intervene. We cannot intervene on the past, on distant galaxies, on events inside black holes. And the very concept of intervention presupposes agency, a being who can choose to act or not. Is agency itself causal? Does defining causation through intervention simply push the mystery one level back? Causation remains elusive, even when we try to operationalize it. Perhaps causation is emergent. At the fundamental level, there are only correlations, patterns in spacetime, mathematical structures that we describe with equations. But at macroscopic scales, with many particles and complex systems, something new appears, reliable regularities that we can exploit for prediction and control. Causation is a useful way of describing these regularities, a higher level pattern that emerges from lower level physics. This view is compatible with physics lacking fundamental causation, while our everyday experience is saturated with it. Emergence allows both to be true. The ball really does move because you kicked it, at the level of description appropriate to balls and kicks. That this level is not fundamental does not make it false. It makes it emergent, real at its own scale. Causation is intimately connected to agency. We think of ourselves as causes, as beings who can initiate chains of events through choice. I raise my arm, and the arm goes up. My decision causes the action. But if causation is problematic, so is agency. If the fundamental level is at causal or time symmetric, what room is there for genuine choice? We touched on this in our episode on time. The block universe seems to leave no room for causation or freedom. Yet we experience ourselves as agents constantly. We deliberate, we decide, we act, and the world changes in response. Whether this experience reflects reality or is itself an illusion remains one of the deepest questions. Causation, agency, and freedom stand or fall together. Even if causation is not fundamental, it is indispensable for explanation. When we ask why something happened, we want causes. Science seeks causal mechanisms, medicine seeks causes of disease, law seeks causes of harm. Explanation without causation seems impossible. This might suggest that causation is a feature of how minds understand the world rather than how the world is in itself. We are causal creatures, evolved to predict and manipulate our environment. Causal reasoning was selected because it worked, because it helped our ancestors survive. But utility does not guarantee truth. The map can be useful even if it does not perfectly match the territory. Perhaps causation is the best map we have, essential for navigating reality, even if reality itself is not fundamentally causal. We began with the obvious. Cause and effect governs everything. We end with uncertainty. Causation might be a habit of mind, an emergent pattern, an approximation useful at human scales but absent from the foundations of physics. This is not a counsel of despair. Understanding the limits of causation deepens our understanding of reality. It reveals how much of what we take for granted is constructed, how even our most basic concepts dissolve under scrutiny. The universe might not be a machine where causes grind out effects. It might be something stranger, a web of correlations, a pattern without a weaver, a dance with no choreographer. And yet, we make sense of it. We find regularities, we predict, we act. We are causal creatures in a possibly acausal cosmos. In our next episode, we explore what happens when chemistry is altered and consciousness is transformed by psychedelics. Until then, remember, the cause of your curiosity might be as mysterious as anything you are curious about. Keep observant.